So today we're going to learn about sequences. What a sequence is, it's a set of numbers in a pattern. So it's just a fancy word for a pattern. And so we're going to be learning different formulas on how to use sequences. So the first thing is you need to understand the symbols. So if we have a sub 1, if you have a little 1 down below, that means it's the first term in the sequence. A sub 2 signifies second term, third term, and so on. You can fill in any number there for that n, and that would give you that number of term. Over here, we're going to do this later on with a certain formula. That just means a previous term. D is common difference. That is what is added each time. R is the common ratio, what's multiplied each time. And n is the number of term that you're looking for. So the first type of sequence we're going to talk about is an arithmetic sequence. And so that is a sequence in which a number D is added each time to continue the pattern. So it's an adding pattern. Some examples of an arithmetic sequence is 2, 6, 10, 14, 18, ... What I do to get to the next number is I add 4. 2 plus 4 is 6. 6 plus 4 is 10. 12, 10, 8, 6, 4, 2. This time it's going down. What we're doing is we're adding a negative number. We're adding negative 2 each time. 12 plus negative 2 is 10. 10 plus negative 2 is 8, and so on. If sometimes it's hard to figure out the difference, if it's really easy small numbers, then it's easy. But if it's decimals or just really large numbers, how you can get your common difference is you take the second term and you subtract it from the first. So A2 minus A1. So what I could have done to figure out the common difference of negative 2 is I would take the second term, which is 10, and I would subtract the first term, which is 12. And that's how I got negative 2 as my common difference. The second type of sequence is a geometric sequence. So that is a sequence in which a number is multiplied to continue the pattern. So it's a multiplying pattern. So an example of this would be 2, 4, 8. So this one we are multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, so on and so forth. The next one, when the numbers are going down, it will be multiplied by a fraction. So I understand that 243 divided by 3 is 81. However, you need to figure out what's being multiplied by. And 243 times 1/3 is 81. And 81 times 1/3 is 27, and so on. So sometimes if it's difficult to find the R, you can take the second term and divide it by the first term. So if I wanted to figure out that the R was 1/3, what I do is I take the second term, 81, and I divide it by the first term, which is 243. And if I would do that in my calculator, I would get 1/3. So now we're going to learn some formulas for sequences. So these are useful because you don't have to count out until a certain number of term. You can just plug it into a formula and figure out the answer. So if it's an arithmetic formula, it's a different formula as if it was geometric. So this is the formula you use if it is an adding pattern, and this is the formula you use if it is a multiplying pattern. And so the directions would read something like this. Find the 32nd term of each. So you could just continue this pattern on and on and on until you get to the 32nd term. But I think that would be a lot of work. And so you can just use this arithmetic formula. So the first thing you need to know is A sub 1. That's the first term. So A sub 1 in this case is 34. N is the number of term. And so it tells me the directions. The number of term is 32. The common difference is what you add each time. So what I'm going to do is I'm going to take the second term and I'm going to subtract the first term. 37 minus 34 is 3. Now that I know all parts of this, I'm going to fill it into that formula right here. So you don't need the first part, you just need what's after the equal sign. So A sub 1 comes first, and then plus, and then in parentheses it's n minus 1. So n is 32. Minus 1, and then the common difference comes after that. All right, and then all you do is you plug it into your calculator. Just how it's written. And if your common difference was a negative, make sure that you use the negative, not the minus sign. I get 127. So if I had continued this pattern out, I would have gotten 127. Let's try another one. So A sub 1 for this next one is -9. The number of term is right here, again 32. And then the common difference, I take the second term and I subtract the first term. And you can do that right in your calculator, and if you did that, you get 0.3. So now I'm just going to fill it into my formula. So it's A1 plus n minus 1, and then the d on the outside. So I grab my calculator, do -9 plus 32 minus 1 and 0.3. I get 0.3. So now for geometric, it is different. This number 3 is a geometric pattern because you are multiplying each time. And so I still need the same information. So a sub 1 is still the first term, 2. N is the number of term, which is 32 again. And then my r this time, I have to take the second term and I have to divide it by the first term. So -10 divided by 2 is -5. So now I'm going to plug it into my formula, which is right here. So a sub 1 is 2, and then I do times. And then my r comes next. Since it's negative, it needs to go in parentheses. And it is raised to the n minus 1 power. So 32 minus 1 is up top. So then I just grab my calculator. I do 2 times. And then -5 in parentheses. Raise it up to the power, and then 32 minus 1. I get this long gross thing. So what that is scientific notation. So this number is really, really, really small that your calculator can't write it out. So what you do is you take the first couple decimal places, and then whatever's after the e, in this case is 21, that's what 10 is raised to. So this is how you would write it. You would write the first 2 digits, so it was like -9.3, and then you do a little x for times, and then 10, and whatever's after the e, which was 21, is the power of the 10. All right, number 4, the first term in this case is 6. The number of term is 32, and then my r is the second term divided by the first term. So 3 divided by 6 is 1/2, or you could just use 0.5. So then I fill it into my formula. So a sub 1, 6 times my r, which is 0.5, and I raise it to the n minus 1, so 32 minus 1. Go to my calculator, and I plug it in. I get another thing with an e. So again, I write first couple decimal places. I'll round that to 2.8. And then I'll do times 10, and whatever's after the e is the exponent, so -9. So 2.8 times 10 to the -9th. Now, on a quiz, you're going to have to decide which formula to use depending if it's an adding or a multiplying pattern. The last one. So this one's different because it gives you this formula, so it means you don't have to use any of the formulas that I've already given you. And it gives you the first term. So once you define the first 5 terms, we already know the first term. And so I need to find the next 4. So I'm going to find the second one first. So I'm going to take this formula, and I'm going to find a sub 2. So I'm plugging 2 in for this n and that n, because that's the second. I'm trying to find term number 2. So I plug in 2 for this n, and I already plugged it in for the first n. So now whenever I solve this, a to the 2 minus 1, 2 minus 1, I'm going to just subtract these 2 and get 1. And so then I can fill in a sub 1. A sub 1 equals 2. So I'm going to fill in 2 for a sub 1. So all this to say that a sub 2 equals 4. So the next term in your sequence is 4. Now let's find a sub 3. So I'm going to take 3 and I'm going to plug it in for both those highlighted yellow ends. So I just replace both these ends with 3. I'm going to simplify the bottom of this, so 3 minus 1 is 2. A sub 2, I already figured out a sub 2 is 4, so I'm going to plug in 4 for a sub 2 times 2. And so a sub 3 is 8. And then hopefully you're starting to see a pattern, 2, 4, 8. And you can just figure out, oh, this is just multiplying by 2. So the next one would be 16. The next one would be 32. The main idea is basically all you have to do is look at what is after the a n minus 1, and that gives you the pattern. The pattern in this case is that you just times it by 2. So I didn't need to go through all that work. I could just look at the pattern and then continue it until I have the first 5 terms.